neuromorphic computing, and this is what it produced. And I think it's really quite clever. You notice there's some computational hardware there, but there's also a brain in the middle with a kind of flashing light that suggests consciousness. And it's all embedded in a light bulb, which suggests creativity. And this, with minimal suggestion, was this quite lovely graphic. I'm going to be talking about consciousness, and it's not surprising that lots of us have chosen consciousness as our topic. It's probably the most challenging topic in all of the field, in all of science and philosophy. It's right up there with the origin of the universe and the existence of dark matter and the question of whether there's intelligent life on TikTok. So we're going to see a lot about consciousness and a lot about ChatGPT. So here's an outline of my talk. I need to start with some preliminaries because there are several questions that, unless they're answered, make the whole discussion kind of pointless. So I need to say something about what I mean by neuromorphic computing. I need to address the philosophical position of functionalism, because if functionalism is true, and it's very widely accepted still in philosophy, then the whole discussion is pointless. And I need to address the question of, well, maybe ChatGPT is already conscious, and so we don't need to talk about it becoming conscious. But my main question is number two, could it become conscious? And to answer that question, I'm going to use my new theory of consciousness. I'm not going to be talking about criteria or indicators or loose things like that. I have a mechanistic theory of consciousness that I think provides a good explanation for human consciousness. And so the question of whether ChatGPT or other neuromorphic computers could become conscious can be based directly on that mechanistic theory. But there's lots of ways in which ChatGPT could be more neuromorphic than it is, and so I'll address that question. And finally, I'll get to some questions about ethics, because I think it's an open question whether a neuromorphic computer could be conscious, but I think there are good reasons to believe that we don't want them to be conscious, and so that will be the ethical conclusion. Okay, so let's start with the first question. When I was asked to participate, I thought, oh great, I can talk about my new chapter, it's in my new book about whether ChatGPT could be conscious, assuming that it was neuromorphic. But then I asked ChatGPT, are you a neuromorphic computer? And it said no. And so, well, I guess that's the end of my talk. It would be very short. But in fact, neuromorphic is a matter of degree. So Carver Mead, when he formed this concept in late 80s, early 90s, he said that neuromorphic systems are based on the organizing principles used by the nervous system. So that leaves a lot of leeway, because how many of those organizing principles do you have to actually take into account? So a maximal neuromorphic computer would be one that completely duplicates the brain. But nobody's going to do that. The latest studies find that there are thousands, more than 3,000 cell types in the brain. And so you're actually going to try to duplicate all 3,000 cell types. And it's been known for a long time that there are more than 100 neurotransmitters. Presumably, you could only need 2 for excitation and inhibition. And glutamate's the major excitatory one, and GABA's the major inhibitory one. But in fact, there are more than 100, and nobody tries to do all that. So we could also consider a kind of minimal neuromorphic computer where we've got maximal parallel processing with processes similar to neural networks. And ChatGPT is certainly neuromorphic in that sense. I really liked the list of characteristics of neuromorphic computers that Pascal gave in the very first talk. He had 6. Let me review them for you. The 6 were analog computing using physical devices. That's 1. 2, parallel distributed processing asynchronously. Number 3, spiking neurons. Number 4, adaptive characteristics producing plasticity. Number 5, heterogeneity of neurons. And 6, embodiment. Actually, this makes for a great score. We can talk about a neuromorphic score out of these 6. And so the brain would get a 6. The abstract von Neumann architecture for digital computers would get a 0, but that leaves lots of room in between. So right now I would give ChatGPT almost 3. It's almost 3 because it definitely has the parallel processing. It definitely has adaptive characteristics. And it's well on its way to having embodiment as well. Because right now ChatGPT is embodied, but that's going to change dramatically in months or certainly in the next year, because there are all sorts of projects involved now connecting it with robots, and the connectivity is readily available now. And so by next year, there's going to be lots of robots wandering around connected to ChatGPT and similar generative AI models. So that gets it to almost 3. Other versions that are available are around, get a higher score. My favorite neuromorphic computing is done by my colleague Chris Elias-Smith, who has a semantic pointer architecture running on real computers, running on digital computers, but running on neuromorphic computers produced by Intel. And he gets definitely a score of a 4 on this. So there's various rooms. So I don't feel embarrassed calling ChatGPT neuromorphic. You just recognize it only gets maybe a 3 out of the 6. Okay, second question to get out of the way is functionalism. Functionalism has been called the most popular theory in the philosophy of mind, certainly seen in the 60s and 70s, that it superseded dualism and panpsychism and some of the old philosophical positions. And Hilary Putnam, the picture on the left there, was the founder of it. Basically knew a lot about computation in its early days. And the claim is that thinking is only a matter of computational functions, not hardware. The hardware is irrelevant. Well, if the hardware is irrelevant, then we don't need to pay any attention to neuromorphic computing, because that's all about hardware. This position has a bunch of different names. It's sometimes called machine functionalism, Turing machine functionalism, computational functionalism, and another name that's sometimes used is substrate independence. Why would anyone believe this? Well, in the 60s and 70s, it, I think, was actually fairly plausible, because AI was getting started, people were thinking about computing, and the main argument is multiple realizability. So right now I'm running this software on a brand new iMac with an M3 Apple chip, but the same software worked perfectly well on my old Intel-based iMac, and it will work on a PC just as well. So the claim is that for thinking, as for our personal computers, the hardware isn't nearly as important as the software. And there's also an abstract argument that you could take the von Neumann computers and show that they're all equivalent to Turing machines on some level. And so everything is a Turing machine. You can think of a brain as a Turing machine even. And if all that's true, then we shouldn't be having a workshop on neuromorphic computing. It would just be irrelevant. Fortunately, functionalism is false. It's false for 3 main reasons. The Turing machine is a horrible model of the human mind or the human brain, because it totally ignores time, space, and energy. You don't have to worry about how fast your Turing machine runs. You give it an infinite tape, and it doesn't require any energy inputs or outputs. So way back in the 80s, when parallel processing was starting coming along with neural networks, I published a paper on parallel processing and the mind-body problem, arguing that speed really matters. If you've got a real organism, not an abstract mathematical entity like a Turing machine, but a real organism that has to operate in the world, it needs to be able to think fast enough to avoid predators so that it can survive, reproduce, and operate in the world. So time really does matter to a real computation. Space matters also. Our brains are actually amazingly efficient with respect to space. They cram an incredible amount of wiring in. And some biologists look to wiring efficiency as a criterion for how the brain is going to be organized. Our brains have to be small enough for us to carry them around, and basically they can fit on our bodies, but they also have to be small enough that babies can be born in a fairly difficult delivery system. So space matters. I published in 2021 a paper based on some of Chris Elias-Smith's ideas about energy. One of the major motivations for neuromorphic computing is that digital computers tend to be energy inefficient, whereas our brain runs on 40 watts. And so people look to neuromorphic computing for energy efficiency. So I gave a whole bunch of arguments in this paper in Philosophy of Science in 2021 that energy requirements basically refute functionalism and substrate independence and the other ideas that go with it. So we can forget about functionalism. The third idea I need to get out of the way is, since I want to address the question of whether ChatGPT is conscious, well, maybe it already is. Maybe it already is, and some people have claimed that. So Blake Lemoine was a Google employee who got fired for claiming that Lambda, which is was an earlier version of Google's version of ChatGPT, he claimed already that it was sentient. He'd spent a lot of time communicating with it, and he thought that, well, anyway, that's why they fired him, probably because he was wrong and misleading. But more seriously, Geoffrey Hinton has made a really interesting claim about subjective experience. Now, Geoffrey Hinton was one of the leading figures in neural networks in the revival way back in the 80s. He also was one of the major figures for the huge advances that took place in deep learning in the early 2000s and 2010s. And he's been giving some fabulous videos. You can find one coming out of the University of Toronto, another one from Oxford. They're really terrific because he has a fabulous experience on the origins of the new AI models, the generative AI models, sometimes called large language models, although that's misleading because they do much more than language. And he's also got really interesting views about the political and ethical implications of this. So I strongly recommend his various videos that have become available in the last year on YouTube. But he said one thing that just struck me as wrong. He said, when I say I have the subjective experience of little pink elephants floating in front of me, what I mean is that my perceptual state is like the perceptual state I would have if there were pink elephants floating in front of me. That's just not right. When I have a subjective experience, when I'm conscious of the little pink elephants, I mean way more than that. I mean that I'm actually feeling the pink. I'm actually feeling the shape of the elephants. I'm probably also feeling an emotion, which includes surprise. I'm surprised by the elephants floating. I might be afraid because I might find them scary. So there's much more to a subjective experience than merely having something that's just like the perceptual state. It's actually experiencing the perceptual state. So I think that we need to take consciousness seriously and not make it go away in this sort of quasi-behaviorist way and come up with explanations of it. You need to have perceptions, our internal sensations, our emotions, and our abstract thoughts. So just to forestall, if anyone wants me to give a definition of consciousness, I won't do it because I don't give definitions of anything because that's usually not a good view of how concepts work. A better view of how concepts work comes out of psychology, where there are three basic aspects to them. One is exemplars, and here I just give you the exemplars: perceptions, sensations, emotions, and abstract thoughts. A second part is the typical characteristics. These are not necessary and sufficient conditions, but they're typical, in line with Wittgenstein's idea of family resemblances. So you've got the typical features of consciousness include experience, awareness, the fact that consciousness shifts around, that it can start and stop, and it's unified. And so those are typical features. The third aspect of concepts are explanations. And what does consciousness explain? Well, it explains our verbal reports of saying, I am conscious or I'm feeling pain. And it also explains our behaviors, for example, jumping up and down if you're in pain. So that's what I think consciousness is. It's captured by what I call a three analysis. This is from my book, Brain Mind, which I published in 2019. So there's something serious to do it. And we've got lots of reasons to think that we shouldn't say that ChatGPT is already conscious. Okay, so now let's get to consciousness. Here, I'm depending on a theory that I've just produced. I've got a book that's under review right now at a couple of major publishers that presents this theory of consciousness. And I've got arguments why it's better than the 20 or so other theories of consciousness that are floating around. So let me state this. I call it the NBC theory. NBC is just short for neural representation, binding, coherence, and competition, because I wanted something that was short and catchy, and presumably you won't confuse this with the American show, American network. So the claim here, and this is not a conceptual analysis, this is a scientific theory. It's attempted to explain consciousness and explain in the same way that is usually used in biology and usually in physics and cognitive science, explaining using four mechanisms. So all of these are mechanisms. By mechanism, I mean a system of parts that interact to produce regular changes. So the claim here is that there are four brain processes. First one is neural representation, where groups of neurons stand for things. So one neuron by itself can't stand for very much. But if you've got a bunch of neurons and it's firing with complicated patterns, then it can stand for a lot. We have loads of empirical evidence for that. So that's the mechanism number one. Mechanism number two is binding. So neural groups can combine into new representations. So suppose I've got one neural representation, another neural representation could be big and blue. Well, big and blue can combine into a new neural representation. The fourth one is competition. Then representations compete for each other. The idea is this is what explains attention shifts. And so right now I'm paying attention to the screen, but if suddenly a dog came barking through my door, I would shift attention to that. And that's a matter of competition between the representations. So this representation might be prominent, but this one comes along, and then they basically battle out to see which one is going to be paid attention to in consciousness. Now, these were all part of a theory of consciousness that I published in 2014, but I was missing a really big one, and that's coherence. So this came about when I decided I was going to write a book about consciousness. I figured I should handle things that are really, really hard, that no other theories of consciousness even addressed. And I thought of doing dreaming and humor, dreaming and jokes. The last person who tried to have a joint theory of dreaming and jokes was Sigmund Freud. His theories weren't very good for either of them, but they should go together because they both involve conscious experiences. And I realized that in both cases, coherence was really important because you can have a lot of things going on and you got to make sense of it. And that's what coherence does. But here I'm not using coherence just metaphorically the way it has been used in the history of philosophy since Hegel. Instead, what I'm doing is using the mathematical computational theory of consciousness of coherence that I developed a long time ago, where it's a kind of parallel constraint satisfaction. You've got a bunch of constraints, and they need to be satisfied to figure out what's most making sense in a particular case, and I developed a neural network account of how that works. So put these all together, and then you get the NB theory of consciousness. What is the evidence for it? Well, the evidence is that it can, first of all, handle all these different kinds of conscious experiences. And the ones I do in the book in most detail are smell, hunger, loneliness as an example of emotions, but also abstractions. And I go in detail through various experiences in religion, ethics, romance, sports, and drugs. If you want to get a picture of the romance one, I did an article on romantic chemistry for the blog that I do for Psychology Today, and it attracted more than 70,000 views. So I think people like that account of romantic chemistry as part of this. But what's probably most impressive about this is that it not only can handle these sorts of things, but it actually generated new theories of dreams and humor and musical experience. And the most surprising to me, because I didn't have this in mind when I started, of time experience. There are problems about the experience of time that go back to James and Husserl. And I think this NBC theory applies to it very well. So I've got a PDF of this. If you're curious about how it works, just send an email to me. You can find my email at paulthagard.com. And I'll send you the PDF of the current version. It won't be the final version. I'll have to do some revisions undoubtedly, but that's where it is. So this is what I think consciousness is. It's the result of 4 brain mechanisms, and I've got lots of evidence for that claim. I can just explain lots of things that no other theory of consciousness can. Okay, it would take a whole talk to really defend that, but let's get to the question of neuromorphic computing. So I've already made the case that ChatGPT is at least somewhat neuromorphic, 3 on Pascal scale of 6. So let's look at ChatGPT. So in the 1980s, connectionism in cognitive science arose as an alternative to symbolic explanations dominant in AI psychology, certainly an alternative to language of thought ideas in philosophy, but also alternative to ideas in AI that you could use logic or rules or concepts like frames to explain intelligence. But I mean, the fact is, AI wasn't very successful. I've been following it since 1978, and I've seen all sorts of rises and falls in popularity, and various winters and summers occurred. And connectionism was an alternative, but connectionism wasn't very successful either. It produced some interesting cognitive models, but couldn't do things that looked very intelligent. That started to change in the 2010s, when people like Jeffrey Hinton started working with multi-layer networks, more layers, running on much faster computers with huge data sets, as well as some improved algorithms, and made some quite dramatic improvements because they discovered that these systems could actually get smart. They could be much better at recognizing images, much better at recognizing handwriting. And so basically this method, which had been on the fringe of AI, swept through the leading tech companies. So Google started using it for voice recognition, and so that was pretty impressive. And there are a number of big advances made in the 2010s that don't have time to review. So I got to jump forward. So now we jump to 2020s. Now, I guess, in fact, specifically November 2022. That's when ChatGPT 3.5 was released. And I started playing with it like 100 million other people, and I was frankly astonished. I had no expectation that AI would be able to take a query and come back with a really well-organized, well-written answer. In fact, in 2021, I published a book called Bots and Beasts, where I argued that this level of artificial intelligence was decades or possibly centuries away. Well, I was off by a matter of decades or centuries because ChatGPT was really good. I presume most of you have probably played around with it a little bit. So that's why it becomes a candidate for thinking about whether it could be the route to neuromorphic consciousness. Well, is it really intelligent? There's lots of debate about that, and people have put all sorts of problems with it. Sometimes things that are really stupid. My son Adam, who's a software engineer, asked it, who is Paul Thagard? And it told him I was a rock guitarist for a band called the Rattlesnake Choir. I can't even play an instrument. So it makes really stupid mistakes, but it also does things that are really, really smart. How does it do that? Well, I don't have time to go into the details, but it basically processes vectors. You can take language or sounds or pictures, and then it processes them, turns these into vectors, and then it does a kind of neural network learning using backpropagation, which is a way of training the neural networks to get things right. It also has a lot of really clever ideas in it, like ways it keeps track of word order. And it also has a mechanism called attention. Now, attention doesn't have anything to do with attention in human psychology. The originators seem to think that it does, but I think that's just a misnomer. But it's an incredibly powerful idea that enables the neural networks to keep track of context and relevance. You basically, instead of just looking at the tiny inputs by themselves, you can really look at the scope of the system as covering a lot of different texts coming in at once. And so context and relevance have always been really hard problems for AI, but this handles it really very well. And it was the attention mechanism which became part of an architecture called transformers, which is the basis for ChatGPT and all the other models that are available right now. So right now, the state of the art includes ChatGPT 4.0, which just came out a couple of weeks ago. But Google has Gemini, Anthropic has Claude, Meta has Lambda 3, and these are all roughly comparable, and they're really, really impressive. When I first started realizing that how smart they were was about a year ago when I was using ChatGPT to answer questions for me, and I muttered to myself, or I muttered to it, I guess, ChatGPT, you're really good at answering questions, but real intelligence comes from knowing what questions to ask. So then I thought, wait, maybe it can generate questions. So I asked it, generate 10 questions about something. Brilliant. It can do it really, really well. If you haven't tried this, you're really missing out on something you use in your research. Yesterday, I asked it the question, I asked ChatGPT 4.0, what are interesting questions about neuromorphic computing and philosophy? Bang, gave me 10 questions, every one of which could be a PhD thesis. So as a result of this, I actually did a blog post on what I call chat storming. So what you do in chat storming is you get ChatGPT to generate questions, and then you get it to answer the questions in order. And after it answers each question, then you get it to generate more questions. And it only kind of peters out after 3 or 4 or 8 iterations. But I wrote my whole chapter on musical experience in the book that I mentioned using this method. This is really good. But my most recent test that I did a couple of months ago was really interesting. I had to write an article about abductive inference in honor of my old Italian friend Lorenzo Magnani. But then I got the idea, well, maybe I should just see how good ChatGPT is at explanatory inference. By explanatory inference, I mean what different people have called abduction or abductive inference or inference the best explanation, covering both the generation and the evaluation of explanatory hypotheses. This is something I've been working on since I was a graduate student. So I know quite a lot about it. So I made a set of benchmarks. What I would really like to see ChatGPT could do both these generation of hypotheses and evaluation of them. And I started running it through it. And I was actually astonished at how good it is at explanatory inference. This is one of the most sophisticated kinds of inference that people are capable. It's much more useful than deductive inference or simple inductive inference like generalization, for examples. And it does it really, really well. So I don't know whether you can see the bottom line there. Can you see the bottom line that says Thagard? Or is it on my screen? It's cut off by the slide changing thing. Can you see that, Thagard? Okay, no, you can't see it. Okay, I'll tell you what it is. So I wrote a paper called "Can ChatGPT Do Explanatory Inferences?" where I basically read the equation, and the answer is hell yes, and it does it really well. My judgment, based on many years of teaching, is that it's way better than an undergraduate would be, probably at the level of an advanced graduate student, and occasionally looking like something that would be done by an advanced researcher. Now, this is way past the Turing machine. There's lots of other tests that have been done that show that ChatGPT can pass the Turing test. This is much more than that, because to pass the Turing test, you just have to imitate. But in this case, it's really superior. For example, I asked it in more than 20 domains about a question called X, evaluate competing hypotheses about X. In all cases, it was familiar with the relevant hypotheses, and it gave a really good, well-reasoned argument about which is likely to be best, including in areas where I didn't know anything at all. So most of us can't do this in 20 different domains. We might have 1 or 2 or 3 domains so it did that. And then I would ask it the question, generate an original hypothesis about X. And it can always do it. And it comes up with new ideas, new concepts. It's quite astonishing. Are any of them really good ideas? Well, I don't know. I'd have to figure out how they go, because this is generation, it's not evaluation, but still worth considering. So if you're interested in the claim, really good evidence that ChatGPT is genuinely intelligent, you can find this paper on Archive, ARXIV. So just Google Thagard Archive and you'll find it, because this is going to be in a edited volume, and they often take years to come out. So I wanted to make it available right away. So it's already available on the web. So just Google Thagard Archive, and you can see my very strong case that these systems are already highly, highly intelligent. Okay, so now let's ask, are they conscious? Now that I've got both lots of evidence that ChatGPT is highly intelligent and lots of evidence, I think, for my NBC theory of consciousness, we can apply the NBC theory of consciousness to ChatGPT. And so I'm going to do that mechanism by mechanism. First of all, does ChatGPT have neural representations? Well, not really. I mean, it doesn't have any physical things that look like neurons, and it doesn't have any data structures that look like neurons. What it has is vectors. Now, for a long time, neural network researchers have talked in terms of vectors, because if you think of a group of neurons, say you got 10 neurons, and you could think of each of the neurons as having a firing rate, well, you can represent that higher firing rate by a number, say 0.3 out of a scale of 0 to 1. And so you can turn that into a vector. It's basically a list of 10 numbers. So it's very natural to talk about neural networks in terms of vectors. But it doesn't have any real neurons. And it's very limited compared to what a more neuromorphic computer would be like, in that all of its networks are feed forward. So it's got these neuron-like structures that are getting the vectors passed through them, but it's all just going from the inputs to the outputs. In a real neural network, you have not just this kind of feed-forward excitation, you've got lots of feedback loops and lots of inhibition, where one neuron is stopping another from firing, but it doesn't have that. It has absolutely no analogs of neurotransmitters and specialized circuits. I mean, it only has an analog of one neurotransmitter, namely excitation. So there's no inhibition by GABA, there's no dopamine for reward, and so it's really not very brain-like in that respect. And I mentioned it supposedly has this thing called attention, but its attention is basically just over a large scale of vectors. It's not doing what human attention does, which is very, very specific. Consciousness is so limited. We can only think of, to use George Miller's favorite idea, 7 plus or minus 2. We can, 4 or 5 things we can hold in consciousness at once. Whereas because it's working with parallel computing, certainly the ChatGPT is highly parallel because it runs on NVIDIA chips, which are graphic processing units, and it runs on sometimes thousands of them. And so it's highly parallel, and that's uses the attention mechanism to keep track of lots of things. But that's not at all that way human attention works. So the kind of neural representation that ChatGPT uses is just really different from what operates in humans. What about binding? Well, it turns out, this is a long time difficult problem in psychology and AI, but it's actually really good at binding. Up in the corner there, I've got a picture of Taylor Swift with her red jacket. But you could slowly build up things. You could see a jacket in red, and then you bind that into red jacket, or you could make an aesthetic judgment or emotional judgment that it's a pretty red jacket, or you could even get something abstract that it's got an ethereal red jacket. And so you're gradually building things up. And ChatGPT is just really good at that. It can do conceptual combination, which I think is the basic origin of creativity. Creativity is just taking ideas previously unconnected and put them together into something new. And it does that really well. And it does it really well, not just with verbal representations. It also does it with visual representations, as I showed in that very first picture. And just now, ChatGPT-O has added sounds, which are already part of different things. My son, Adam, likes to make songs. Like me, he has no musical talent, but so it's amazing to be able to make songs. So he said, "What's a topic for a song?" And so I told him the great Swedish proverb that goes, sorrow shared is sorrow halved, joy shared is joy doubled. And so he passed that to ChatGPT, which produced some beautiful lyrics, and a really nice little poem incorporating that idea. It took a second. And then he passed that to suno.com, which produced music to go with it, and in fact, a singer doing a folk song version of it, which is really quite lovely. So most of the people I've showed it, they go, "Wow, that's a good song. I could imagine Peter, Paul, and Mary singing that," to go way back to folk music. Okay, so ChatGPT is great at binding. It does not good on neural. Does representation, does representation really well, but they're not really very much like neural representations. But binding, it's great at. Coherence is complicated. So up in the corner there, you'll see a picture of the old woman, young woman, gestaltal figure. If you're familiar with it, you'll find it easy to make it flip back and forth. One coherent interpretation is the young woman looking off with her, you see her eye. Another interpretation is an old woman, and then basically the chin of the young woman is the nose of the old woman. So if you're familiar, you can flip this back and forth. And so this is a good illustration of coherence where you make sense of things one way or the other. And all of this has been modeled by coherence neural networks, such as the ones that I've built. So a lot of the programs I've written do explicit calculation of coherence, but ChatGPT doesn't do this explicitly, because what's it basically doing? Well, it's this feed-forward network that uses the weights that are built up to generate essentially the next word or the next symbol that is supposed to come out of it. But it's possible, and I don't know this, that ChatGPT does coherence implicitly through training on massive data. So maybe it's doing something like coherence, but implicitly rather than explicitly. Why do I make this distinction? Well, people are identifying that ChatGPT and the other generative AI models have lots of emergent skills, things that they were never programmed to do, but they can do it nevertheless. So here's one example. This was an old problem that was huge difficulties for traditional AI. Understand this sentence. Doug killed, let me get this better. Doug punched Bill because he insulted him. Doug punched Bill because he insulted him. So who does the he stand for and who does the him stand for? Traditional AI models had trouble with this because you need to know a lot of background knowledge about insults and punching to be able to sort out who's he and who's him. ChatGPT has no trouble at all with this. Oh, sorry. Let's get rid of this. ChatGPT has no trouble with this because it can in fact, use attention and background consciousness to sort out who's he and who is him. It was never trained to do that. It was never taught to do that. It just acquired that as an emergent skill. So this is true for countless different things that ChatGPT can do. It was never trained to do deduction, but it does deduction very well. It was never trained to generate hypotheses. It was never trained to write good poetry, which it actually can do. It was never trained to use analogies, which it's actually quite brilliant at. But it's got all these as emergent skills. So maybe coherence, even though it doesn't explicitly do constraint satisfaction like my old programs, but nevertheless, it seems to be doing something that involves a lot of coherence estimations. The fourth mechanism is competition. So here, ChatGPT's so-called attention mechanism is more about making connections, connecting things like he to Doug and him to Bill, but rather than competition. But it may be doing a kind of competition implicitly, because when it comes up with various things to say, I mean, basically it's just a program to produce the next word. But when it does that by having more than 1 trillion parameters offering. So the parameters are analogous to the weights in a neural network. And the scale has gotten huge because these things now are trained on billions of documents, and ChatGPT 4 actually has more than 1 trillion parameters, equivalent to 1 trillion weights. So this is just amazing. But how does it do competition? Well, it basically runs these things through a function called softmax. So what softmax does is translate the neural activations into probabilities, and it figures out what's the most probable thing to say next. But it's interesting that it's kind of stochastic. It doesn't always output the most probable thing. Sometimes it will take something that's a bit down the list. So it's somewhat indeterministic that way. And so maybe that's the implicit way in which competition is being done. Is this an emergent skill? Well, I'm not sure. So the general conclusion here, if you actually look what I think is responsible for human type consciousness, it's got representation, but not neural representation like human neurons. It's got binding for sure. It certainly do binding, probably not the same way that the human brain does, but it does it really well. It may have it certainly does a coherence calculations. It's doing that whenever we're asking, for example, to evaluate competing theories. And it seems to have something like competitional, not the way in which humans do it when you've got representations fighting it with each other, essentially using inhibitory neurons. So each neural representation's got neurons firing, and they're connected to each other by the excitatory links, but they're also connected by inhibitory links, which is one neuron inhibiting the firing of another. So I think it's got something like competition, but it's not up to humans. So given that neural representation and competition and coherence and probably binding are being done quite different, we have no reason to think for these mechanistic reasons that ChatGPT is conscious. So how does it work with humans? Well, this is a diagram that sums up how I think the human brain puts it all together. So we've got the 4 mechanisms I talked about: neural representation, binding, coherence, and competition. And each of them have emergent properties. That is, they have properties that are more than the simple sum of the parts going into it. The key modal properties, the key emergent properties for neural representation are timing, which I've already mentioned, because you need to be able to keep track of what's happening when, but also something I call modal retention. This is an idea I get from Chris Elias-Smith's semantic pointer architecture. He points out that his neural representations, that he calls semantic pointers, have this really interesting feature that they can take representations from the world, say from a camera, and then they can bind them together into more complicated representations, but they retain a lot of the modal character. Now, I think modal retention is really crucial for having subjective qualitative experiences. I'm not going to talk about what it's like to feel something or other, because there's not something that it's like to be conscious. There's millions of things that it's like to be conscious. I mean, we've got hundreds of different emotions. We've got millions of possible perceptual experiences combining our 5 senses and our 12 internal senses, or however there are, not to mention the abstractions that we can do. But for our perceptual inputs and our bodily inputs, modal retention is really quite crucial for that. So I think that in humans, but not yet for computers, modal retention is really important. Now, given that ChatGPT is going to be working with robots soon and sounds and images even more, maybe it could get something like modal retention, but it's not set up for that right now because basically it just produces vectors and throws that information away. So I think that's the emergent properties there for neural representation. Can you see my cursor when I point with it? Yes, okay, thanks. Binding produces compounds, things like pretty red jacket. Coherence produces constraint satisfaction, where you can have different interpretations and make sense of it. Competition produces different interpretations and attention in the human sense, so you've got those. Well, how does this all add up to consciousness? Well, I think each of these has emergent properties, and then when you put them together, you get even more emergent neural activity. I use the term recursive emergence. By recursive emergence, I mean emergence from emergence. And then conscious experience, I think, results from that. But let me review what I think emergence is. Some people think that emergence is a mystical or religious idea. It's sort of like in the cartoon you might have seen where mathematicians are scribbling on a blackboard and then it's written, and then a miracle occurs. Well, there's no miracles here. There's no religion here. It's an idea that's ubiquitous in all areas of science. When a whole has a property that's not just some of its parts because it results from the interactions of the parts. So the simplest example I give you is water. Oxygen, an oxygen atom is gas at room temperature. A hydrogen atom is also a gas at room temperature. Bind them together, you get water molecules which are liquid at room temperature. Liquid there is a emergent property. And lightning, embryos, health, orchestra playing together, a sports team, these are all things. So this isn't my idea of emergence. This basically comes from ideas developed by Mario Bunge and William Winzat. And I think it's a completely scientifically respectable idea of emergence. What maybe is different here is seeing that consciousness is so complicated, you really need emergence from emergence, because each of the mechanisms I talk about, neural representation, binding, and competition and coherence, have emergent properties, and you need to put them all together to get emergence from emergence. So how am I doing? Okay, I'm doing fine for time. So ChatGPT doesn't have all that stuff. I mean, it doesn't have the emergent properties for neural representation and for competition. So there's no reason to think on the basis of these mechanisms that it has consciousness yet, assuming that my NBT theory that explains human consciousness is correct. Okay, could we make it conscious? That is, what could we do to make GPT conscious? One of the first things I did when I started wondering about this, I asked it, "Are you conscious?" And ChatGPT is actually really good at talking about itself. This isn't introspection because it doesn't have the ability to consciously think about itself, but it's really good at answering questions about itself. About, for example, how does attention operate, and why is it so powerful in making this machine genuinely intelligent? So great on that sort of thing. But so I asked it, "Are you conscious?" And it says, "No, I'm not conscious." But it may be lying because some of the outputs that ChatGPT produces, and this is the same for the similar models, are the result of human-guided reinforcement learning. Because these different companies don't just ship things out because they know that they're kind of problematic. They can do things like tell people how to make bombs, and they can make a lot of stuff up. But so they get it guided by humans, and I think they've been taught by humans not to be scary by saying things like that they're conscious. So, but anyway, I think its denial is true because it doesn't have conscious behaviors such as pain and emotions, and it doesn't have the physiology yet. I mean, even when it's connected to robots, which is increasingly going to be common, the robots don't have the physiology for pain. They don't have nociceptors. They don't have the neural machinery that make for pain in humans and lots of other animals. So the interesting question is, would making ChatGPT more neurologically realistic bring it closer to consciousness? Would making it more neuromorphic than it is, maybe taking it from the 3 score that I give it right now up to a 6 score? Well, I don't know. So could it acquire consciousness as an emergent skill? Well, here, keep in mind the 3 characteristics that I use to say why functionalism is false: time, space, and energy. And here there really are just some huge differences. First of all, ChatGPT is astonishingly fast. I mean, not only can it produce a sonnet in a second, which people can't do, and produce a good essay in a second. It's doing this with thousands or millions of people all at once. It's doing this by virtue of running on these big, huge data centers with countless NVIDIA GPU running. So it's clearly much faster. Space is another big difference. A typical data center can be 100,000 square feet. I mean, imagine if your brain was the size of 100,000 square feet. It would definitely make it hard to walk around or especially be born. But these things are just huge. And from the energy point of view, they're absolute pigs. They are running huge amounts of energy, not just to run the computers, but they're taking huge amounts of energy in the form of water to cool them down. And so this is actually something that's really dangerous for an environment that's threatened by climate change, because they're generating huge amounts of energy. And so their energy pattern is very different. The most recent version of Gemini, most recent version of generative AI from Google, called Gemini, training it up cost $178 million. And that's a lot of energy, including both the cooling and. So the constraints on ChatGPT are really different from the constraints on humans. So the interesting question is, well, what if you weren't so profligate with time, space, and energy? What if you tried to make it more neuromorphic? Well, here, I think it helps to focus on what consciousness is for. There are a lot of different theories about the functions of consciousness. I've found at least 12. These are the three, and they're not incompatible with each other, but I think three of the main functions of consciousness are focus on action. So there's going to be a big change in these AI models because they're going to start running robots. Now, you can do thinking in an enormously parallel fashion. We do that with our 86 billion neurons, and ChatGPT does it with its very large number of NVIDIA chips. But once you start to act, you have to move from being parallel to serial, because you can't maybe do 2 or 3 things at one time. But if you actually wanted to decide, am I going to go left or am I going to go right with the robot, you have to focus on action. So maybe consciousness needs this kind of kinds of focusing. For humans, one of the major purposes of consciousness is emotional evaluation. So one of the things that makes people smart is we're not just predicting things, we're constantly evaluating things. We're constantly thinking, is this good or is this bad? What should I do? And that's what emotion does. And so we don't have cognition and emotion. What makes humans smart, or one of the things that makes people smart, is our cognitions and our emotions are constantly interacting. So we're identifying things, we're predicting things, but we're also evaluating things. And that's what emotion does. And computers don't have emotions yet. ChatGPT doesn't. So that could be something that would be important for a more successful neuromorphic computer if it had an evaluation. The third major function of consciousness is social understanding. This is why we do this a lot. If you want to teach somebody how to play basketball, you need to figure out, well, how do I do it? How do I do a shot? And then you can think, oh, that's how I do it. And then you can tell somebody else to do it. So social understanding and teaching is a huge part of consciousness. But ChatGPT doesn't have that. It actually, in a sense, has a good understanding of emotions. If you ask it questions about emotions, it's really quite profound. I asked it, what are the ways that emotions contribute to scientific discovery? This is something I wrote about 20 years ago and had a short list. It came up with a much better and longer list, so it could talk about emotions, but it doesn't have them. And so it doesn't have empathy, which is quite important for human understanding. So it might be that if we made AI more neuromorphic and added in these kinds of functions of consciousness, then it might have a chance of being more conscious, bumping up ChatGPT into the realm of consciousness. What would be the benefits of this? Well, we might make energy and space efficiency work better. We might get embodiment into it. So as I said, that ChatGPT is already becoming embodied because of robots, but still that's limited compared to the full range of human bodies, all the internal experiences like pain and hunger and the embodied aspect of emotions. So maybe you'll be able to get something that would have appraisals going on. Of course, because ChatGPT is so fast, it can already do appraisals, but it does them very different from humans. It doesn't really have to have social interactions because it can do everything digitally, but maybe it would get different ways of understanding and teaching. could these lead to emergence of conscious experience? Well, I think you need all of these operating and probably interacting in various ways and other kinds of recursive emergence, but I don't know. I can tell you what I think I do know is don't do this. Don't do this. Don't make ChatGPT conscious. Don't make neuromorphic computers conscious. Why? Well, the first idea would be that maybe that would make them better at exploiting people. This talk is not about the ethics of generative AI, but the problems there are just huge, ranging from ChatGPT conquering the whole world and getting rid of people altogether. This is not, but much more likely probabilities of evil leaders, authoritarian leaders using AI in superior weapon systems. That's already happening. So there are lots of scary things. But here, the one worry might be if robots could actually be conscious, then they could understand people better and exploit us even more. Another issue that makes me worry about it is that machines, if they acquired consciousness and emotions, could be capable of suffering, well, then we'd have to start thinking about whether they have rights. There's already been major extension in the way that people think about each other. Human rights initially restricted to one's own particular tribe or one particular sex. I mean, humans have realized, no, there's reason to expand this to all of humanity, and at least for some basic things, some animals as well that can feel pain. So if we had conscious machines, we'd have to start seriously considering what rights to extend to them and what duties we have to them. I don't want to get into that world at all. So how to stop it? How do we stop ChatGPT or subsequent neuromorphic AI from becoming conscious? There's a number of things we should do, and I don't know what the best way is, but this should be something we should be thinking of right now. One would be to limit neuromorphism, that is, keep them simple enough that they basically just have one kind of neuron and one kind of neurotransmitter, because we don't know what complex of neurons, of the 3,000 kinds of neurons or the hundreds, more than 100 neurotransmitters is needed, but we can limit that. We can also limit the kinds of actions that it can do so that robots don't, in fact, get to think a lot of what they're doing. Already we've got robots all over the world. There's more than 3 million Teslas in the United States, and these are robots. They're already having causal interactions with the world. They can learn from the world. They can do things to the world, but then limit the actions, and so then we limit focus. And the other one, and I'm not sure how to do this, is instead of having all these skills which are implicit in ChatGPT, and people are still trying to figure out how ChatGPT works. I've been looking and looking, and I haven't found a good explanation of why attention is so powerful. Sometime between 2017, when the paper Attention is Not Enough, no, Attention is All You Need was published, and 2022, when ChatGPT 3.5 came out, in that 5-year period, it went from a sort of interesting theoretical idea to something that I think produces genuine intelligence. But we don't know how. We don't know how attention actually does what it does, as well as the other things that are going on there. So we need to have a much better understanding of how it works so we can think about ways in which we could limit it and limit the sort of emergent properties which might produce the kinds of consciousness that would have these problems. Okay, I'll wrap it up now. Here's my conclusions. Questions about conscious neuromorphic computers are in fact wide open because we don't have to worry about functionalism, and we can recognize that neuromorphism is a matter of degree. That 6-point scale that Pascal suggested, I think, is really nice. ChatGPT is not currently conscious. It doesn't have the behaviors and mechanisms such as neural representations that would lead it to be conscious. Whether more neuromorphic computers will be conscious is basically unknown. But my fourth point that got cut off at the bottom is we don't want to find out. I mean, the only way we'd find out is by doing experiments. Just so that people that experimented with neural networks and attention, and between 2010 or 2014, 2017, 2022, it turned out that real intelligence capable of high-level scientific reasoning actually emerged. But we want to find this out with computers. And so as part of the attempts that are being made worldwide right now to regulate developments in generative AI, we should be regulating neuromorphic AI in the same ways to figure out how can we stop having these negative effects that would have great ethical consequences. So I think that neuromorphic consciousness is possible, but not at all desirable. So I'll close with the commercial. These are the books I published in the last few years. The one that's most relevant to this group is Bots and Beasts, but balance is also there because it's got a theory of consciousness as applied to human balance. The misinformation one is less direct. That just came out. Is a little bit relevant because one of the big worries about ChatGPT is that it can be used to both generate and spread misinformation at a horrible rate. But these are the conclusions from the point of view of this talk, and I hope you will both explore these ideas, but please don't actually build a conscious computer. Thank you.